In the previous tutorial, /post/Rust tutorial wasm/, we explored WebAssembly. Now we learn Unsafe Rust, what it means, when you need it, and how to use it without breaking Rust's safety guarantees. Let's break it down. Raw pointers are like references, but without Rust's safety guarantees. Creating a raw pointer is safe. You can create as many as you want. But dereferencing, reading or writing through the pointer, is unsafe because the pointer might be null, the pointer might point to freed memory, the pointer might be misaligned. Multiple mutable raw pointers can exist for the same memory pointer arithmetic. You can do pointer math like in C. ptr.add I advances the pointer by I elements, not bytes. Unsafe functions that have safety requirements the compiler can't check are marked unsafe FN. This creates two mutable references to different parts of the same slice. Normally, Rust forbids two mutable references to the same data. But here we know they don't overlap, so it's safe. Building an unsafe data structure. Let's build a simple vector from scratch to understand how vec works. The key operations: ptr.add in.write value writes a value at position in without dropping the old value. ptr.add in.read reads a value at position in, moves it out, and ptr.add in creates a reference to the value at position in memory allocation. Growing the vector needs manual memory management. Drop implementation: when the vector is dropped, we must free memory and drop all elements. Drop __ place runs the destructor for each element. Then deal lock frees the memory block. If we forget either step, we leak resources. Unsafe traits: an unsafe trait has invariants that the implementer must guarantee. The unsafe on the trait means implementing this incorrectly can cause undefined behavior. For zeroable, the invariant is that zeroed must return a valid value for the type. Not all types can be safely zeroed. For example, a non-zero U32 zeroed would violate its invariant. You can then use it safely. FFI, Foreign Function Interface. FFI lets Rust call C functions and C call Rust functions. This is inherently unsafe because C has no safety guarantees. Here's a simulated example of C-style string operations. In real FFI, you declare external C functions and call them in unsafe blocks. The extern C block tells Rust these functions use the C calling convention. Transmute. Type reinterpretation std. MEM. Transmute reinterprets the bits of one type as another type. This is useful for inspecting the binary representation of values. Use transmute sparingly. Prefer F32 to _bits and F32 from _bits for float conversion. They're safe and do the same thing. Union types. Unions are like enums, but without a tag. All fields share the same memory. Reading a union field is unsafe because you might read the bits as the wrong type. Unions are mainly used for C interop. Rust enums with repr, C, are usually a better choice. Static mutable variables. Global mutable state is unsafe in Rust because it can cause data races. Every access requires unsafe. In multi-threaded code, this is genuinely dangerous. Prefer atomic I32 or mutex I32 instead. No unsafe needed. The safe wrapper pattern. In practice, the most important skill with unsafe Rust is building safe abstractions. Here's an example: a vector that guarantees at least one element. This doesn't use unsafe, but the pattern is the same. Invariants are enforced by the type system. First, never panics because the struct always has at least one element.